If there are no questions on any of the assignments so far, we're going to go on and get started with the lesson today. So,
thank you so much.
So, our steps that we've had so far with solving radical equations was first, is there one radical? If yes, get it by itself. If no, even them out. The second step was to put both sides to the nth power, simplify from there. Our third step, if there's more than one radical, repeat steps 1 and 2. And the last step was to solve. And up to this point, step 3 really hasn't had any impact. We haven't had any use for it because once we put both sides to the nth power, all the radicals were gone. Yes, sir.
Wait, so there's only 2 questions. Okay.
What? We're going to look at this here because this is different than what we've covered so far. Now, when we look at this first problem here, there is more than one radical. So that's nothing new. We've done problems with more than one radical before. Now they are evened out, so that means we can put both sides to the nth power. We can put both sides to the second power. Now on the left-hand side, the square root and square will cancel, leaving us with 2x is equal to Now, since we have 2 terms being added together, like yesterday where we had 2x plus 1, where we had to multiply it by itself, we have to do the same thing here. Because the square in that radical for the x plus 7 won't just cancel each other out. Because we also have the minus 1. Questions on this so far? Now the left-hand side is still going to be 2x, but the right-hand side we have to use our distributive property. We have to multiply this out. So we're going to have the square root of x plus 7 times the square root of x plus 7, which is going to give us the square root of x plus 7 squared. And really that square root and square will simplify out. They will cancel out, which will make this a little bit nicer to work with. And we'll do that next. So we'll have the square root of x plus 7 times negative 1, which is going to be negative square root of x plus 7. We'll do the same thing with the negative 1. We'll distribute it through. Negative 1 times the square root of x plus 7 is going to be negative square root of x plus 7. And lastly, negative 1 times negative 1 is going to be plus 1. Now at this point here, we can simplify and combine like terms. Now our square root and square will cancel, giving us x plus 7. Now technically we do have this 1 over here that we can combine with our 7 because 7 and 1 are like terms, yes? And if we add those together, we'd get what? Now the only other like terms that we have are our 2 radicals, and we can combine those since they are the same, giving us negative 2 square root of x plus 7. So at this point here, we've done steps 1 and 2. Steps 1, more than one radical, we got them evened out. We put both sides to the nth power, our second power, and we did simplify that. Now step 3, this is the first time step 3 has actually come into play, because at this point, do we still have a radical? Well, yes. Since we still have a radical, we're going to repeat steps 1 and 2. So at this point here, we look back at this and see, okay, we do have a radical, so we're going to get it by itself. To get it by itself, we need to move the x, 8, and negative 2. So the first thing we can do is subtract x from both sides. these will cancel. 2x minus x will give us x is equal to 8 minus 2 square root of x plus 7. Again, the radical is not by itself, so the next thing we can do is subtract the 8 from both sides, which will tell us that x minus 8 is equal to negative 2 times the square root of x plus 7. So still trying to get the radical by itself. Now the only thing that's still left with the radical is the negative 2. Since they're being multiplied together, to undo that, we would divide both sides by negative 2. Which gives us this here. Now we don't have to worry so much about the 2 being negative because the x, the variable, will take that into account and offset it. Now do we have the radical by itself? Yes. So now we can put both sides to the second power. And luckily enough, the square root and square on the right-hand side will simplify, leaving us with x plus 7. So it took us 2 times going through this, but now all the radicals are simplified out. Now on the other side, x minus 8 divided by negative 2 squared is being multiplied by itself. So it's saying the numerator, x minus 8, is being multiplied by x minus 8. The denominator is telling us that we have negative 2 times negative 2. And out of all the multiplication on the left-hand side, the denominator is the easier of the two to multiply together, because negative 2 times negative 2 is 4. Now with the numerator, we can multiply this through. X times x is going to give us x squared. X times negative 8 is negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 is going to be plus 64. Any questions on anything we've done so far? Now we can combine like terms in the numerator, guys. Now we can combine like terms in the numerator here, because negative 8 minus 8 is going to be negative 16x. Now we've got it down to this point, we've combined like terms. We see that we do have a quadratic, the x squared. But getting this equal to 0 might be a little challenging, especially with the division of 4. This is actually, the step we're going to do next is very nice, and it's kind of interesting that it actually does work this way. Because if I multiply the entire left-hand side by 4, what happens? Those 4's cancel, yes? So if we multiply the entire equation by 4, we're left with x squared minus 16x plus 64. Our fraction, guys, our fraction on the left-hand side is gone, because that was what's going to make the next steps more challenging if we still had the division of 4. On the right-hand side, we'll multiply x by 4, giving us 4x, multiply 7 by 4, giving us 28. So that multiplication of 4 took it from something that was going to be quite challenging to actually something that's not as bad. And lastly, we just need to get this equal to 0. So we can subtract 4x from both sides, telling us that x squared minus 20x plus 64 is equal to 28. Minus 28 from both sides tells us that x squared minus 20x plus 36 is equal to 0. Any questions on how we got to this quadratic? Now at this point here, we can solve the quadratic by factoring, graphing, quadratic formula, any of the methods that we've had so far. Now since the variable, or not a variable, but the coefficient in front of x squared, the number in front of x squared is 1, it's positive 1, we can graph this to get our solutions. So here we can type it in, x squared minus 20x plus 36. And when we graph it, we're trying to look and see what values of x will make the y value be 0. And as we already saw, which y'all saw already, we found 1. X is 18. Now, for any quadratic, we need to have two solutions. Well, exactly. Because what factors of 36? 18 and 2. So most likely. 2 is our other solution. Any questions on how we found 18 and 2? Now, this one here, because we're almost finished, we do need to check it. But as we look at all these steps here, with having two radicals and a number being added or subtracted to it, did the difficulty from step to step get any harder than what we've been doing the last few days? Not really. It's still the same kind of steps we're going through one by one, except after we finished squaring both sides, we didn't finish with an equation, a quadratic, where we didn't have a radical or a square root left. We had to do it again, and then we got to the end. It's just we had to repeat the steps more than once. Now, the last thing we need to do is we need to check this to see and make sure that both solutions do work. Now, again, when you check these here and when the test, especially on the test, says to check your solutions, the first thing you'll need to do is plug the number in. So for x equals 2, I plug 2 in for x. You can do it by hand. You can do it in the calculator. So for the left-hand side, square root of 2 times 2 is 2. So the entire left-hand side of the equation is 2. We can do the same thing with the right-hand side. You can grab the calculator and say second square root of 2 plus 7 minus 1 is 2. So both sides are the same. 2 is equal to 2. So that tells us the solution x equals 2 works. That one of the equation does work. Now we can do the same thing with 18. Guys. Now we can do the same thing with 18. Plug it in and check and see what we get. Roy, guys. Square root of 2 times 18 gives us 6. So the left-hand side of this is 6. We can do the same thing with the right. Second square root, 18 plus 7 minus 1 is 4. Those are not the same, so it tells us that x equals 18 is not the correct solution. So the only one that is correct is x equals 2. Bless you. Any questions on any of this here? So, and again, I wanted to show you guys this because, for one, it is possible to solve these. And going step by step, it's not anything harder. It's a lot more steps. But the individual steps in what we do, it's not any more challenging than what we were doing before. It's a lot more steps, and once we see how they work and how they operate, they make sense. It works out. But again, unless we've seen how they work, it can be a little confusing on actually how we solve them. Now, I'm going to let y'all have the rest of the time to work on your previous assignments and get those done and get those turned in, because some of you do have a few assignments to do. So you need to take advantage of that time to do those there. There is not an assignment attached to this here. So use the rest of this time to work on the previous assignments.